Today we're going to look at what the graphs of all these things we've been talking about look like. Specifically, quadratic functions, which are written in the form y equals ax squared plus bx plus c, where a is not 0. If a is 0, it ends up being a line. The graph of a quadratic function is a parabola. P-A-R-A-B-O-L-A. Parabola. A U-shaped curve. The vertex is the highest point, aka a maximum, or the lowest point, aka a minimum. So sometimes we have something that really does look like a U, and we would say that its vertex is a minimum. Or we might have something that looks more like a hill or a mound, and we would call that vertex a maximum. The axis of symmetry is the vertical line that cuts my graph into two symmetric pieces and passes through the vertex. It is always written as x equals a number. If you don't put the x equals part, it is wrong. And finally, the zeros, remember that word, are where the graph crosses the x-axis. They're also known as x-intercepts or solutions or roots. Any of those words mean the same thing when we're talking about quadratics. And some of this is information we can get from our equation, y equals ax squared plus bx plus c. If a, our leading coefficient, I'm just going to abbreviate that, is greater than 0, that means that a is positive, then the graph opens up. If a is less than 0, which means a is negative, then the graph opens down because negative people are a downer. The other thing that a can tell you is whether it is skinny or fat. So as a gets larger, the graph gets skinny or stretched out. If it's getting smaller, and by that I mean it's going towards 0, then it gets fatter. So A gives us our direction of opening and our width. C happens to be our y-intercept. So let's look at an actual graph of what this might look like and label. So first of all, I have my vertex. That is this lowest point. So that would be my vertex, and we would call it a minimum. Where my graph crosses the x-axis, remember those are called my zeros, or solutions, or roots, or just plain old x-intercepts. My axis of symmetry, or AOS, once again that's axis of symmetry, cuts my graph in half. If I wanted to actually give the value of these things, my vertex is at the point 0, -3. My two x-intercepts are -2, and 2, and remember we can put those in a bracket, not parentheses. And my axis of symmetry would be x equals 0, because that vertical line, so vux, is going through the point x equals 0. Let's look at a couple more examples. So this is wanting me to find my x-intercepts first. So I see one here and one there, approximately. That looks like -3 and -1 to me. So those would be my x-intercepts. Remember, I can call them zeros as well. My y-intercept, that's just where my graph crosses the y-axis, which is right there. So that would be +3. My vertex is my lowest point of my graph, and that is at the point -2, -1. I went left 1, down 1. The vertex has a minimum value. If you think kind of about a little ant crawling along my graph, let me see if I can get my pen to work. He's crawling down, 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 and you really can't. There we go. Going down and then up. He is going down, and then he can't get any lower than that bottom part of the U shape. So we would say it's a minimum. The minimum value is my y value of my vertex. And then my axis of symmetry, I can look on my graph, or it's x equals the x value of my vertex. So x equals -2. So once I found my vertex, I've gotten 3 different things. I've got my vertex, I've got my max or min value, and I've gotten my axis of symmetry. And just so you can see it, let me graph the line, x equals -2. And it's dotted because it's an axis. It's not really a line. It's just showing something on our graph. Okay, let's look at another example. Same thing, x-intercepts. So my x-intercepts where it crosses the x-axis. I see one right there at 3, and one there at -1. Remember, don't put them in parentheses. Then I need my y-intercept. Once again, it ends up being 3. It's not always going to be 3. My vertex is the point 1, 4. And from this, I can get to other things. It has a maximum. It's a hill. There's a place where I can't go any higher on my graph, but these arrows mean I can keep going down forever. So my maximum is my y value, which is 4. So that means I can't get a y value higher than 4. And my axis of symmetry is x equals the x value, 1, of my vertex. Check it on the graph. It looks beautiful. Another thing is this graph opens down. So another thing we want to talk about is direction and opening. It opens down. Because if you kind of imagine the arrows are your hands and you hold your hands like that, your hands are facing down, as opposed to, let me flip back to number 1, it's opening up. My hands would be reaching towards the sky. So this one opens up. Okay. And finally, this one looks just a little bit different. Notice I only have one x-intercept, and that's at 2. My y-intercept almost looks like it's at, nope, it's at 4. Almost thought it was at 3. That would have been too funny. Okay, so my y-intercept is at 4. My vertex is the same thing as my x-intercept. It's at the point 2, 0. Not 0, 2, 2, 0. The vertex has a minimum, and the minimum value is 0. I can't ever go any lower than 0 on my graph. And my axis of symmetry is x equals the x value of my vertex. So x equals 2, if I draw that line on there, it works. So this one is something that, just so you know, this is called a double root. Because instead of having 2 roots or 2 x-intercepts, I only have 1. And tomorrow we'll see some examples where I don't have any. But that's it. Complete your notes. Make sure that if you have any questions, you're ready to come in with them tomorrow.